Hi, we're Group 5 and we're going to be presenting about bioterrorism. So this is the table of content and I'm responsible for the background part. So first, what is bioterrorism? It is defined as the deliberate release of viruses, bacteria, or other germs to cause illness or death in people, livestock, or crops. Using microorganisms or infected samples, it causes terror and panic in populations, and these germs are often found in nature but can be made more harmful by increasing their ability to cause disease, spread, or resist medical treatment. Bioterrorism agents. Bioterrorism agents spread through the air, water, or in food, and some can spread from person to person. They don't cause illness for several hours or days, and it's really hard to detect. And the examples include anthrax, botulism, plague, smallpox, and so on. And getting in deeper, Bacillus anthracis, which is the bacteria that causes anthrax, is one of the most likely agents to be used in a bioterrorism attack. And anthrax is commonly used because anthrax spores are easily found and developed. It can be released quietly, and the spores can be put into different forms, such as powders, sprays, food, and water. So it's been used as a weapon around the world for nearly a century. And how did it start? It began with the Hittites of Anatolia during epidemics from 1500 to 1200 BC. They sent infected animals and people into enemy rooms in order to cause outbreaks, and such infectious diseases were recognized for potential impact on people and armies as early as 600 BC. So polluting wells and other sources of water of opposing army was a common strategy that continued to be used in many European wars and the American Civil War. And in 1346, during the siege of Kaffa, the attacking Tartar force experienced an epidemic of plague, and during the 14th and 15th century, plague was spread all over and caused over 25 million deaths in Europe, and various uses of disease were found in many other wars. And in the 15th century, other disease called smallpox has been used as an effective biological weapon in the New World. So, on numerous occasions during the past 2,000 years, the use of biological agents in various forms have been recorded in historical events. And now moving on to the 19th and 20th century, where the use of biological warfare became more sophisticated. By the time World War I began, attempts to use anthrax at animal populations were recorded. And during the World War I, several evidences suggest that Germany launched a biological warfare in the United States of America, Russia, Romania, and France. However, Germany denied all these allegations, and in 1924, a subcommittee of the Temporary Mixed Commission of the League of Nations in support of Germany found no definite evidence of Germany's employment of bacteriological arm of warfare in war. With response to the horror during World War I, international diplomatic efforts limited the development and use of weapons of mass destruction, such as biological and chemical weapons. And in 1925, the Geneva Protocol of 1925 was signed. Then during World War II, some countries began biological warfare research program again. And even after that, today, experiments and use have been continuing in some countries in spite of certain restrictions. And now I want to share one of the most well-known examples of bioterrorism. 2001 anthrax attacks, also known as Amerithax, is one of the most popular anthrax attacks happened in 2001. In this case, anthrax spores were placed in letters and mailed to several media companies and congressional offices in America. And due to this, 5 people died from inhaling anthrax and 17 others were infected after exposure. So this is a brief timeline of the incident. So on the September 11, 2001, terrorists hijacked 4 airline jets and crashed them into several regions in America. Then on September 18th, a week after the terrorist attack, the first letters containing anthrax were mailed. Then on the October 5th, the first death due to this incident was reported. And on the 9th of October, more letters were posted and FBI begins investigating the incidents. And many people were tested positive for anthrax, and the investigations have been fortified during this period. And on November 21st, the last victim, the fifth anthrax death, was reported. And even after that, for many years, FBI investigation continued until 2011. And this incident is popular and well-known because it became one of the largest and most complex in the history of law enforcement.
I'm Mou Long Chun, student ID 557435XU. I'm responsible for doing the objective and categories of bioterrorism. Since my group may talk about the definition of bioterrorism, we can just go through it directly. So the objective of bioterrorism is to draw attention to social media in order to rebel the basis of social, economic, and political unfairness, or showcase the religious ideology. Here is the categories of bioterrorism. According to the risk to the national security, biologic agent can be categorized into three priorities. They are category A, B, and C agents by dissemination, mobility, and mortality. In categories A, they are easily disseminated and they are also high mortality. These agents are able to cause public panic and social disruption and require special public health preparation. In category B, these agents are moderately disseminated and moderate mobility. This kind of agent require enhanced surveillance and diagnostic capacity. In category C, this kind of agent are able to replicate for mass dissemination, and they have potential for high mobility and mortality in the future. Here is the example of each category. In category A, we have plague and apheresis, also Ebola virus. In category B, we have Salmonella species. In category C, we have multi-drug resistant tuberculosis.
Yersinia pestis is known as kind of bacteria that causes plague, and it is also known as the most serious bioterrorism agent in the world. It is very famous for black deaths in Europe as it causes skin black, and a lot of people died in a short period due to pestis in Europe. So for the natural infection route, it is primarily from rodent and it could be spread by infected fly and direct contact through wound in skin. Furthermore, allergy could be a route as well. This is our mechanism for infection. Firstly, we assume that there is a bite from rodent fly as it is common in these days. Then the bacteria invade directly host via skin. Thirdly, the bacteria encounters phagocytes and macrophages which are part of human immune system, but pestis could infect them and proliferate in the macrophage. Finally, bacteria will released and spread in our body. So there are mainly three types. Firstly, bubonic plague. It is most common among three of them and is named bubonic as the lymph node cord bulbs are infected and swollen. It is normally through fly bite and has an incubation period of 2 to 6 days. Hopefully, with quick treatment, over 90% people could survive, but without treatment, it can be developed into septicemic plague through bloodstream. Secondly, septicemic plague. It is due to infection through bloodstream, so it causes blood infection called septicemia, so several bleeding problem followed by sign of shocks. So with prompt treatment, 75% to 80% of patients would survive. Finally, pneumonia plague. It is due to infection through aerosol, so it infects lungs and causes pneumonia. Can be from both bubonic and septicemic. Of course, without treatment, it is highly fatal. So these are the symptoms of each type. For the bubonic plague, swollen lymph nodes and chills, headache, fever, weakness. And for the septicemic, fever, abdominal pain, chill, shock, tissue bleeding, tissue death, tissue goes black. And for the pneumonic plague, chest pain, shortness of breath, cough, fever, nausea, chills, vomiting, and diarrhea. So what makes it strong bioterrorism agent? Firstly, why pestis can be easily found around the world and advanced technique lead to mass production and aerosol dissemination. Also, it has high fatality without treatment and easy transmission. Then antibiotic resistant strain of why pestis exists in nature. Finally, there is no commercially available vaccine. For biological weapon in mid of 1930s, Japan tries to invent biological weapon by using plague. There are two methods were considered. Firstly, use explosive force to disperse as aerosol to cause pneumonic plague, and secondly, dispersing infected flesh directly to cause bubonic plague. and both of them were considered to be used with Uji bomb as a carrier. Not only Japan, several countries like USA and Soviet Union also tried to produce biological weapons using Y pestis.
Anthrax, which is an infection that is caused by the bacteria Bacillus anthracis. It is a gram-positive bacteria. It has a general structure of a gram-positive bacteria, but notably it has a capsule. This capsule gives the colonies a very slimy mucus-like appearance, and also on the right is what it looks like when it's grown on an agar plate. It forms these long chains. There's 4 forms of human anthrax infection, and they're categorized by their mode of entry. There's 1, cutinous, where spores enter our body through cuts on the skin. Gastrointestinal, when we eat the meat of infected animals. Inhalational, which is what we'll be talking about, when we breathe in the bacterial spores. And there's injection, when we inject ourselves with materials, usually heroin, that is contaminated with spores. So they actually all have different symptoms depending on their mode of entry, but we won't go through them due to time constraints. Treatment. For treatment, we will treat it using antibiotics. For severe cases, we'll inject the antibiotic straight into the bloodstream and use a combination of antibiotics, such as the one on the right, for inhalational anthrax. So, mechanism of attack, it relies on 2 of its features to harm us. The first feature is a protein capsule made of a polygamma D-glutamic acid, and this capsule allows it to inhibit phagocytosis by our host neutrophils, thus allowing it to escape immune surveillance or any phagocytes. Now, 2 is it produces anthrax toxins, which is a mixture of 3 proteins. These proteins are called protective antigen, edema factor, and lethal factor. Now, they work together. We'll see how they work together. PA, protective antigen, acts as kind of a Trojan horse. So it will, without PA, the other 2 toxins cannot enter the cell, thereby rendering it useless. So PA first attaches to a cell surface receptor. It is then cleaved. When it's cleaved, it will form 2 fragments. The smaller fragments just dissolves and no longer plays a role. The larger fragment will bind with 6 other PA of the same size or the same fragment. And once this will form a kind of a ring-like structure. EF or LF can then bind into this ring-like structure, forming a complex. This complex can enter the cell through a process called endocytosis. And during endocytosis, an endospore with a lower pH is formed. The lower pH in the endosome triggers the release of EF or LF into the cytosol of the cell. Now, once it is in the cytosol of the cell, EF and LF can trigger different sets of reactions. For EF, the result of this reaction is edema, which is tissue swelling. For LF, the result of the reaction is cell death. Now, it's suitable for bioterrorism because it can be released very discreetly. You won't be able to tell if these spores are in your food, or in the air, or in the water. And it can also be found in nature and can be reproduced in the lab fairly easily. And it can be stored for a long time once the weapon is made, and it can persist within the environment for a long duration once it is released onto the environment. And the last 2 points can occur as a result of the formation of endospores. So these bacteria can form very resistant endospores. They're even resistant to 95% ethanol.
I would like to introduce some of the preparedness against bioterrorism in the United States. The first convention that covers the use of biological and chemical weapons is the Geneva Protocol, which was signed in 1925. This protocol only bans the use, but not the production of such weapons. Also, it only bans the use of bacteriological bioterrorism and seems to exclude virus attacks. The Biological Weapons Convention, BWC, is the convention on the prohibition and destruction of development, production, and stockpiling of any types of biological weapons. BWC is a result of continuous effort by the international community to supplement the 1925 Geneva Protocol. BWC now has 178 state parties. However, both the Geneva Protocol and BWC only applies to the states' use in warfare, which means that the use by non-state actors and the use in situations other than warfare were not restricted. In order to cover these defects, United Nations Security Council Resolution 1540 was signed in 2004. UNSCR 1540 is an international agreement that most directly addresses the prevention of bioterrorism. It focuses on prohibition and destruction of biological weapons of non-state actors. Despite the presence of legal instruments, it does not guarantee for prevention of biological terrorism. However, along with other strategies, the risk might be reduced. Coping with bioterrorism includes preventing spread of biological weapons, methods for detecting hidden biological weapons, deterring biological weapons if they do spread, and lastly, mechanisms for protecting civilians and military populations if the deterrence fails. Among all these methods to cope with bioterrorism, the focus should be on defense simply because proliferation of biological weapons is difficult to control. Hidden biological weapons are difficult to detect, and deterrence is likely to be less effective against those suicidal terrorist groups. Therefore, research and development should be focused on defense against biological weapons. Biodefense mechanism includes surveillance, detection, and diagnosis. Surveillance and rapid detections are crucial to an effective response to a bioterrorist attack, since delayed detection results in delayed treatment, which is likely to increase spread of the diseases. There are several innovative surveillance systems in use or being developed, including ROADS and Essence. Real-time outbreak disease surveillance ROADS was first launched in 1999. It is the first automated bioterrorism detection system which collects data from the lab, hospitals, and environmental studies in order to detect bioterrorism as soon as possible. Essence is an automatic syndromic surveillance system that initially relies on already existing automatic healthcare information system. Since September 11, Essence has been extended to over 300 installations around the world. Every 24 hours, 30,000 ambulatory diagnoses from these various installations are downloaded, automatically analyzed, prioritized based on expected values from historic data, and visualized using geographic information systems. In addition, vaccines for bioagents that cause smallpox and anthrax are available at the moment, which prevents the infection in the case of an outbreak. Civilians can get vaccinations in advance to prepare for the possible bioterrorism in the future.